Welcome, math lovers. I want to take this moment to talk about the mathematics through the ages. That is the big benchmark for this course. So as we go through the course, you're going to do a lot of exploring of mathematics, and you're going to also make little presentations. While you're doing those, it would benefit you to consider the history of mathematical thought. You're going to create a PowerPoint timeline tracing the milestones in the development of the different fields of mathematics through the important contributions of different cultures and individuals, including at least one or more important individuals and one or more distinct cultures that made significant contributions to each of the fields of mathematics studied, as I'll go over. Make sure that you include in your timeline the following. At least 6 scholarly sources, different scholarly sources. You prepare this assignment according to the guidelines in the APA Style Guide located in the Student Success Center. The assignment does use a rubric. We will go over that at the end of this presentation. But please review the rubric prior to beginning the assignment to become familiar with the expectations for successful completion. You are required to submit this assignment to Lopes-Wright. Link to Lopes-Wright technical support articles is located in the class resources if you need assistance. Most of you have used Lopes-Wright before, and you will. For this, you are going to trace milestones in the development of each of the following: concepts of numbers, quantity, and number systems in both the present and the past, significant findings in the study and development of algebra, including the important individuals and cultures who contributed to the field of study, historical significance of geometry and trigonometry, including important individuals, cultures who contributed to these, statistics and probability as fields of mathematical study, and you're going to include, again, important individuals and cultures, and historical progression of calculus, including the influence of important individuals and cultures, and then the history of discrete mathematics, including important individuals and cultures. That's the idea behind this. So first, let me give you some samples to help you with the final project. These are 2 different ways to do it. These are the ones that I often use, but I also have permission to use a few students' works. So here's an example. This is a very rough example. Here we're seeing the timeline, and then we're seeing some key points. So Pythagoras, numbers rule of the universe, wind, Euclid, Archimedes, etc. And you'll notice that these either continue all the way through to today. You would then put milestones in with a little short description. You would not try to fit everything on one timeline. Please do not do that. There is not enough room for everything that has happened in the history of man. Just not enough. So you're going to have multiples of these. You might color code and talk about particular things. Maybe you want to do numbers in one color and then do calculus or algebra or whatever in another color, and you have different colors for everything. That is totally fine. It can also help to connect things when you're going over them. You can also do the timeline focused on a particular subject. So maybe you only do the timeline for numbers and number quantities and systems. So you go over that, and then you go into algebra and you have a timeline for algebra, and then you have a timeline for statistics and probability and discrete and etc. So you can do it as individual timelines like that. You can do it where it's incorporated into one timeline. These are all choices you get to make. And then here's another example. Here, same general people. We start with the beginnings. So we have Pythagoras, Euclid, and Archimedes. Again, you'll notice that these are done different colors. So that's a good opportunity for you to do different colors or different patterns. I've seen where they do icons, and that's fine too. So here is an example from a previous student's work. So mathematics through the ages. This is his final or her final presentation. The fields of mathematics to look at: numbers, counting, algebra, geometry, trig, statistics, probability, calculus, and discrete. He gives us what we're going to go, he or she, I don't remember on this one, gives us specifics on which ones we're going to go over. And then here we have counting and numbers timeline. So you'll notice this is broken up by what they're going over. So they're going to do numbers and counting systems. So beginning with the La Bamba bone, dated around 35,000 BC. And this ranks as the oldest known math artifact. Going in and briefly touching on each one of these. You would do this in your presentation. I'm not going to present their presentation to you. But throughout this, there might be something that you want to pull out. There should be. If you were just giving me a timeline, you're missing the point of this. The idea is you're going to pull out some things that you feel are important. Now, one of the things that this person felt was important was the Egypt develops a base 10 counting system, which is still the system used today. And so here we have where they pulled that out and they talk about it. And then, because that's not quite where we're at, right? If you look at that, that's technically 9. I know you see a 10 there, but technically it's only 9 digits. He or she incorporated the development of 0, which is awesome, and talks about it. So these are 2 things that they felt to pull out from their timeline to talk about. And that's what I expect from everyone who's doing this. Then we get on to algebra, and he talks about algebra. And he begins with the Babylonians and clay tablets all the way through Descartes, which is a wonderful place to go. And the things he chose to pull out here, or she chose out the Babylonian clay tablets. Again, here showing up, and beautifully so, you'll notice the numbers that are imposed on the clay tablets. That's to translate the numbers that are written there, because you haven't learned to read cuneiform yet, but you will. So he wanted to make sure that everyone, or she wanted to make sure that everyone remembered what those symbols meant. So included those, and then continued on, and also wanted to talk about Renee. So there we have the quadratic equation that most of you have memorized using some form of this. And there it is. Next, geometry and trig. Again, still back with the Babylonians, all the way through the Islamic art and complex designs, which they use for geometric patterns. And some of the key points there. Chose to pull out more Babylonian. This person must have enjoyed the section on Babylonians. Here, you'll notice that the numbers are not put on this. So now they're just figuring that you've caught back up and you remember how to do it from before. And then included the progression of the unit circle. And here The conversation is what was going on to create it, where it comes from. But not just that, they also included a nice unit circle here, which is very nice. And then they go on to statistics and probability. I noticed that here there's no tick marks, to show about where these things are in time. I also noticed that they're discussing statistics and probability from Cardano, and I think the O just got left off. Pascal, Vermont, Grant, Huygens, and through Bernoulli's. But it would have been nice to see something from the current use of statistics also. Let's see, what is pulled out here? The choice to pull out was mortality rates that John Grant had done. And also Bernoulli's law of big numbers. So that's pretty nice. Showing a nice table too. Beautiful. And again, on each of these, this isn't the only, he didn't read these, or this person didn't read these slides, he or she, because I wouldn't have bothered to put it in if they had. I would have been very disappointed. Not that he didn't go over each one of these bullet points. He or she went in depth on this. Now we have the history of calculus. Sadly, they only chose to begin with Newton. A little disappointed because we talk about calculus way before this, and does go all the way into 1722 with Roger Coates. Of course, the focus that they chose to pull out was the Leibniz and Newton disagreement, if you will, and then also chose to discuss some of the first calculus textbooks. So that's always nice. For discrete math, beginning back with Euclid and the greatest common denominator theorem, notice no tick marks. That would have been nice to see here, just to keep track of about the distance between each one of these. Through Gauss and Euler and into present day, though it would have been nice to see some specifics in present day. The example that he chose to pull out, or he or she chose to pull out, was the wonderful Königsberg problem, which we, of course, will explore way later in the semester. The other thing that needs to be, again, I mentioned that you need to have 6 scholarly sources. This is not how you do sources. Not at all how you do sources. Sources should be in the notes page of this slide, and in the notes page of this slide, and in the notes page of this slide. If you do that and cite your sources as you're using them in your notes, clearly your notes will say what you're going to say or approximate what you're going to say, and you would have citations in there, and at the bottom of your notes page, that notes page would have the particular reference that you used. Putting them at the end is really not a good idea. And putting them just as these links is not appropriate. Here's another example where they chose to go just down the timeline. And let's take a look at that. The history of mathematics, student name. And I will say that in the student notes, Hello, my name is student name. Today I will be talking about the history of mathematics. It's very nice to see notes, slide notes, well written. I've used a color key system to categorize my events. Here's the key. Numbers, quantity, or number systems will be in the yellow, algebra, the blue, geometry and trig in the purple, probability and statistics in the red, calculus in the green, discrete mathematics in the orange, and other major life events, things that were happening in the world, will be in a gray. The Ashango bone, oldest mathematical artifact in existence, that is the beginning of numbers and counting. There's a very long time between that and the next where we find the Sumerian multiplication tables. These are very old, as they were as early as 2600 BCE. From there, we see the pyramids of Giza being built, which was a crazy establishment in geometric knowledge from Egypt. Nobody really knows how they did it. Other than that, it is up and standing. From there, we see 1,000 years later, the Rhind Papyrus was written, and this was a collection of 84 problems about multiplication, division, fractions, and geometry. These are things that he has in his slides and his notes. And I'm going to briefly go through them. You'll notice the color coordination of stuff as he goes through the timeline. Or this one is a he. I do know who this one was. Then we talk about the first Olympic Games held in Greece. Again, that is not an event, but it is an event. It's not a mathematical event, so those are in that gray. And he does go into talking about each one of these. The choice to pull out was Euclid. Very wonderful choice to pull out. And he does talk about Euclid, what we do know about Euclid, more importantly, about his works. And then again, we're now to 260 BCE to, there's no 0 year, to 0 approximately. Oddly, there isn't a 0 year, but we do go into Jesus Christ being born and the unknown beginning of Christianity. Again, talking in detail about these events. Some more events, talking about the Library of Alexandria being destroyed. And that was a significant effect for us. And then he pulls out Muhammad al-Khwarizmi and talks about him. Wonderfully so. We're going to talk a lot about Al as we get to that in the semester. Some more wonderful mathematics throughout this, even taking time to talk deeply about Leonardo da Pisa and Yang Hu, but not enough to pull out a slide. So I thought that was kind of cool. The Gutenberg, the invention of the press, that's a wonderful blessing that we have. And then going on here with Fermat's theorem, Leibniz and Newton, and he does go into detail of briefly of Fermat and stuff, and then he does pull out Newton and talking about him. Then we go back in and we talk about the Königsberg problem, Lampert and Gauss, also America. And talks a little bit about that. And then we move in and Samuel Morse, so the Morse code. We talk about the Klein model, Mobius strip, and Albert Einstein. And that appears to be what he wanted to talk about. What a great picture. Talks about him and tells some stories. And then we get here, and he's going into modern times. I will say that the Enigma computer was not created to decode Russian messages. That's actually not correct. But yeah, Great Depression did happen. Stephen Hawking's, and he actually goes up through Hawking's, and that's about where he ends. And then he did his references at the end. These are actually how references are supposed to be written. This is APA format. And he did, which is great. Again, I think they don't necessarily belong in their own slide. They belong for each slide, but let's take a look at the rubric. So the rubric criteria applies to each one of these concepts, mathematical concepts. So numbers, quantities, algebra, geometry and trig, statistics and probability, calculus and discrete. So there are 6 main mathematical fields that we're talking about. And for each one of these, to get the full 5 or the full points, your timeline expertly tracks the milestones in the development of this concept in both the present and the past. The timeline is comprehensive and insightful with relevant evidence to support claims. Timeline demonstrates an exceptional understanding of the topic. And then you can read what's acceptable, what's approaching, insufficient. Timeline inadequately tracks. So an example on his, if I go back to, I think it was, this is inaccurate information. This 1939, this is inaccurate. The Enigma was actually a code designed by the Germans, but the Enigma computer that would be breaking it was actually designed originally by a Polish scientist, but the British and the US used it to decode Nazi or Axis powers and helped us win the war in 1945. But this is when we first started development of it after we'd gotten it from the Polish people, the Polish scientists. So that's inaccurate information. That means that when I look at over here at the rubric, that's not quite target. Now, it's not bad. It's not way down here. It's not inadequately, it's not like insufficient, where the timeline inadequately tracks the milestones in the development of this concepts in both present and past. It's missive evidence to support claims or poor understanding of the topics. It's not that far down. He is right. It is part of the discrete mathematics, but it's not down here, or I'm not sure what color he put that on, but it's not down here and insufficient. It's up here and acceptable. I could see that in both statistics too, either statistics or discrete, whichever one he chose to put that in. That would timeline strong, sound analysis, some evidence to support claims, and demonstrates an understanding that extends beyond surface topics. There's just some mistakes. There's a few others. I'm not by any means, neither one of these were perfect. Some of them were better than others, but I wanted you to see an example of what I consider a good presentation, and both of these were good presentations, and both earned passing scores, so we're okay there. Neither one of them earned 100%. That's not That takes serious work to get there. Unsatisfactory, those are 0 points. You're getting nothing for them. If the timeline omits or incompletely tracks the milestones in the development of this concept in both the present and the past, lacks evidence to support claims, does not demonstrate understanding of the topic. If you put one thing in for a particular topic, maybe when we talk about Muhammad al-Khwarizmi, and you decide that's the one thing you're putting in for algebra, and you leave every other discovery in algebra out, that's unsatisfactory. Yes, you put somebody in there. No, that is not okay. It's like you're going to do calculus and you only put in Newton or you only put in Leibniz, and you don't discuss the many people before them or the many people after them that helped it happen. Not okay. Okay. You need to have, and I'm not saying you can pull out just that one. You can absolutely just pull out Newton. You could absolutely just pull out al-Khwarizmi, but you have to give me more information about the field of the algebra or calculus and other discoveries. They can be bullet points. They don't have to be the thing you pull out, but you have to give me more information. The other thing that this is, I'm gonna grade on is gonna be presentation of the content. This is when you're in front of the class and you are presenting it. The layout, I need the layout to be the appropriate layout. Don't mix the two. If you're doing where you're gonna go through a particular field first and then you're gonna do another field, that's fine. But don't try to mix the fields then. Don't do, okay, I'm doing separate fields, but now you may have something that applies to one field and applies to another field, and you want to include it. That's fine, but you have to apply it twice. So don't mix the layouts. Have a good, strong notes pages for your slides. And this is where language use and audience awareness include sentence construction, word choice, etc. This is important because you know you're presenting this to your classmates and me. If you're not aware of where the audience is and what they know and don't know, or what we've gone over and what we haven't gone over, that's going to hurt you here. Okay. And I don't want anybody losing points for these things. I'd rather have it be because you missed something. Documentation of sources. These include citations, footnotes, references, bibliograph, etc., as appropriate to the assignment and the style. Again, citations where you're using a reference to something should be in your document notes. They should not be on the slide itself. Just down below. If you're including a picture of something, you could include a citation below it saying that's where the picture comes from. That's okay. But other than that, I expect the words on the slides to be your own. I expect what you say about it to maybe include a citation where you're getting this information from somewhere. And then you would put the references in there. You could do a page of references like he had done. I'm okay with this. This doesn't feel horrible, but these should all be cited inside his student notes and in his slide notes, and he absolutely did do that. I think these belong at the end on their own, not on a slide, but in the slide notes as a preference, but you can totally put them here. Most of you have this idea, this is where you put them, and that's okay, but you do them like this, not a bunch of links. I don't want to see a bunch of links. Okay. This is your ending class assignment. This is the big one. This is going to be discussed multiple times. This is your final project, Mathematics Through the Ages. We're going to discuss this throughout the semester. Please make sure that you're being aware as you do your smaller ones, your topic presentations, that maybe you're saying, oh, I might be able to use this slide. I want to mark that. I want to make a point of that because that could be useful in your Mathematics of the Ages final presentation. My hope is that you have less to do here because you've done the work leading up to this. All right, that's my brief discussion on the final benchmark. Have a good day.